sort of startup checklist or startup sheet in their installation manual for the contractors to use while doing their startup. So filling in this information, sometimes, you have an install crew with multiple people on the job, filling out different information or doing different things, pertaining to the installation. So the key information that's put on that checklist or in that, those information fields could be critical. Are you the one that did the install? Are you the one that filled out the startup sheet? Is there, possibility that someone made a mistake somewhere? So writing all this stuff down, ensures that you've got proper matching equipment, to the application that you're installing. So first things first, look around. Is the area where your condensing unit's going to sit, is it level? Is there, is there a chance for erosion where, it could possibly affect that unit, a year or two down the road? Other instances, maybe a heat pump. You have, gutters overhanging the unit that could cause ice buildup and not allow the unit to defrost properly. Those little things will save you a lot of heartache down the road. Looking around for those little things and making sure that you don't have anything like that affecting the installation of your product. And as you go through the startup checklist, go through and check each item. These checklists don't take very long to fill out and scope out the project. So as you're going through, fill each one out as you go through the process, and ultimately it's going to save you time and money. So after this case, we've scoped out the condensing unit location. We've verified clearances and location, so we check those off as we go. Always check your data plate on your equipment. Make sure it matches what you ordered. Because the last thing you want is to install a unit and then find out it's the wrong unit. Electrically, things you should look for. This is an example. A wire came disconnected from a transformer, and when you go to do a startup on a brand new unit and the unit doesn't come on, when you first try to start it up, you're going to be pretty upset. So check all the electrical, factory electrical connections, things like that. Make sure they're tight and nothing's come disconnected during shipping. And again, check your data plate, make sure everything's proper for the application. Make sure your voltage is the same voltage that's specified on the nameplate, matches the application that you're going in, and check those things off as you go through your list. Make sure your fuses don't exceed the max fuse rating on the nameplate. Make sure your wire is sized correctly for the circuit feeding the unit. Metering devices. Nowadays we see two typical types of metering devices in the field. We have your orifice style and your TXV. More commonly nowadays is the TXV due to certain efficiency standards. On TXV installation, you have a sensing bulb. That bulb exerts pressure on the diaphragm to adjust the opening of that expansion valve. The sensing bulb is always installed on the outlet side of the evaporator, and needs to be wrapped with insulating tape. Now, some coils will already have this done for you, but in some cases, when the TXV needs to be field installed, you will have to do that manually. But you want that insulating bulb wrapped in insulation, so it's sensing directly from the line and not air temperature around it. All right, Matt, I've got a quick poll question here real quick. If you wouldn't mind, go ahead and get that launched here. All right, looks like 50% of the people have voted. We'll give you just another minute or so. All right, Matt, if you would go ahead and close the poll. Looks like we got the majority of the people voted. Let's see. Matt, can you share the results? For some reason, it's not letting me do it. Okay, so it looks like 86% selected pigtail up, 14% selected pigtail down. All right. The correct answer is pigtail up. Typically, it is a refrigerant that is in that sensing bulb responding to the temperature. And refrigerant contains oil. So if that sensing bulb is mounted in the downward location with the pigtails down, you have the potential of the oil in that refrigerant blocking your capillary tube. So the correct answer is pigtail up. All right, so here we go. We've installed the TXV or verified the TXV bulb mounting location or the fixed metering device. We're made sure that we have proper matches for the equipment that we have selected. So we check that off as well. We've also verified that our line set tubes are not touching any foundation, floor, ceiling joists, wall studs, anything that may cause any kind of harmonic vibration that may transfer into the home. Okay, and as usual, you always want to make sure your suction line's fully insulated. When it comes to evacuation, a simple little process here can help save you a lot of time. Using a Schrader core tool and removing the Schrader core allows you to pull vacuum a lot faster. Sometimes can even cut your time in half when it comes to pulling a vacuum on a system. Nowadays with 410A refrigerant, depth of vacuum is critical. As we all know, 410A is a very good detergent. So, pulling the microns down to 500 is essential. When verifying your vacuum, this is just a simple little chart indicating, over time, if your micron level continues to rise, you have a leak. But if it rises and then levels off, you've still got moisture in the system. Always use nitrogen when brazing. The same scaling that you see build up on the outside of the copper when you're brazing is the same scaling and oxidation that builds up on the inside. And with 410A being a detergent, it will wash that oxidation off the piping and will end up stuck somewhere in like a TXV or a strainer and create a restriction in the system. So proper brazing techniques require the use of nitrogen while brazing. Okay, so we've gone through the refrigeration system, verified no leaks, pulled a proper evacuation. So now we go to the manufacturer's chart. We verify the charge, gives us our subcooling value, which is typically also listed on the data plate of the equipment. And some manufacturers will also give you their charge adder amount for additional charge. 410A with a 3/8 liquid line is typically 0.6 ounces per foot. Okay, so if we've got our refrigerant charge checked and verified, okay, we're now going to verify that our fuses and disconnects are proper for the application. Make sure we return it, disconnect to the on position to get ready for the startup. Also want to double check our thermostat wiring, make sure when we kick this system on, we're not going to blow a fuse. We want to double check, make sure we don't have any shorts. Pay close attention to premium equipment that may have dip switches that may need to be set for different applications. Verify those with the manufacturer's installation instructions. When you get into premium furnaces with variable speed blowers, those dip switch settings are critical to get the proper airflow delivery. And always check your static pressure and then compare to your blower CFM delivery charts. Okay, this could be the difference between an angry homeowner and a very satisfied homeowner. The days of wiring up a system and walking away are pretty much over. We all know the PSC blowers are going to be going away next year. So, with that being said, the minimum blower that you're going to be able to get in a furnace is going to be an X13 motor, in which case still requires speed tap selection and static pressure measurement and compared to a blower chart to find your airflow delivery. Air handlers contain similar circuit boards. They're going to have, some sort of jumper pins or dip switches that are going to need to be set to, for proper airflow delivery. And again, the X13 motors are going to have, speed taps, just like, similar to a PSC motor. However, some manufacturers don't always program every speed in that motor, so pay close attention to the installation instructions to make sure that you've got the proper airflow for the application. Let's talk about drains for a minute here. With the efficiencies and components in gas furnaces nowadays, some of the things we run into consistently where on high efficiency furnace applications are drainage issues where people don't pay close enough attention to the installation instructions. So what I want to highlight here, and the major takeaway here, is most manufacturers now are requiring some sort of vent right at the outlet of the furnace. So if you have an evaporator coil or an air conditioning system that you have commonly drained with a furnace, okay, that furnace is going to require that connection to be a standoff. Okay, so that being said, there should be an open standpipe that evaporator coil drains into. So in other words, it's got to have an air gap around it to be able to pull in air to help the system drain properly. Otherwise, that positive pressure from that evaporator coil is going to affect your pressure switches in that furnace. We always check for gas leaks. Obviously, you want to check with some sort of leak detector solution. You don't want to use a lighter. That could end up very, very, very badly for somebody. Always check your incoming pressures with a full load. So you want any gas appliance in that house or structure operating while you're checking your gas pressure. That's going to ensure that you're going to be able to maintain gas pressure with all those appliances running at the same time, as seldom as that happens. And for premium equipment like modulating furnaces and two-stage furnaces, always pay close attention to the installation instructions for manifold pressures. Some manufacturers are different than others. They require different pressure settings. Another key takeaway here is specifically on the ICP. On the ICP product, I know our LP kits require a minimum of a constant 12 inches water column to that gas valve. Okay, the range is 12 to 13.6. I have seen recently on a few occasions where the current regulators on the house could not deliver that constant 12 inches. Clocking the gas meter. This is one way to ensure that your furnace is delivering the proper capacity. And most manufacturers now are putting instructions in their installation manuals to walk you through clocking the gas meter to ensure that BTU delivery. Checking temperature rise. Temperature rise is a critical part of the startup. All right, it's going to ensure that the furnace is operating within the manufacturer's specifications. It's going to provide the homeowner with the comfort level they expect. It's going to extend the life of the equipment. Now, two things to keep in mind. A low temperature rise typically indicates high airflow. High temperature rise typically indicates low airflow. If you target the middle of that temperature rise range, that's going to allow you a buffer for any issues that may arise, with homeowners letting air filters go a little too long before changing, things of that nature. So if you target with your airflow, if you target the middle of that temperature rise, that's going to allow you a little buffer to eliminate nuisance calls from those types of things. Temperature rise is also useful in determining CFM, which we'll go over here in just a second. Okay, product specifications are going to show you the temperature rise ranges, for different furnaces. Okay, a lot of times those temperature rise ranges are actually listed on the unit's rating plate as well. Temperature rise method calculation is a calculation used to help you determine CFM. So using that temperature rise and plugging it into a formula will allow us to estimate the airflow that we're moving through the system. And that formula is as follows. CFM equals the heating capacity, which is the heating output, so BTU output of the furnace, divided by 1.08 times your temperature drop. That formula will allow you to estimate the amount of CFM that you're moving through the system. So checking your temperature rise, obviously you want a return, you want to get a measurement for the return air coming back to the furnace. But checking your supply air temperature, you always want to check it up around the corner of the plenum. Okay, you do not want a direct line of sight to the heat exchanger to eliminate any radiant heat that you could pick up off the heat exchanger. In applications where you have multiple trunk lines coming off of a plenum, then you're going to want to take temperatures in all three of those, or all, each trunk line, and then average them out to get your supply air temperature. So in this case, if we have 135-degree supply air with a 70-degree return air, that gives us a temperature rise of 65 degrees. So this same method can be applied with electric heat as well. Okay, using the same formula, we modify it a little bit. So the same formula can be used, however, finding the BTU output is what changes a little bit. So on the electrical side of things, we can use volts times amps times 3.414 BTUs. Okay, there's 3.414 BTUs for every watt of electricity used. So if we take that, we can determine our BTU output capacity. And then you plug that in and use that in the BTU output capacity spot in the formula, and the rest of the formula remains the same. So in this case, we have 230 volts multiplied by 45 amps times 3.414 BTUs per watt. If we divide that by 1.08 times our 28-degree temperature drop, tells us we're moving approximately 1170 CFM. Air conditioners and heat pumps. Installation instructions are a critical tool and contain very, very valuable information when it comes to installing or servicing a piece of equipment. Sensor location when charging via superheat, subcooling, sensor locations are critical. So always make sure that you're reading your temperatures in the proper locations when determining superheat and subcooling. Okay, most manufacturers provide you with design temperatures, amp draws, things that pressure readings in certain, application temperatures. So always pay attention to these, to these charts. We've got another poll here for you real quick. Matt, if you wouldn't mind, go ahead and launch that for me here. All right, looks like we got the majority of the people voted. Matt, you want to go ahead and close it and share the results, please? Okay, looks like 67% of the people voted for subcooling, 33% voted for weighing in the charge, and 0% for superheat. The actual most accurate way to charge a system is by weight. Charging charts will be the second. Typically, charging charts are subcooling nowadays. But you know, the fact of the matter is weighing in a charge can be done year round. All right, so where superheat and subcooling calculations, the temperatures have to be in a certain range for you to be able to do that accurately. So weighing in the charge is going to be your most accurate, most effective way for charging a system. Most outdoor units typically come pre-charged for a 15-foot line set. Longer line sets and larger indoor coil matches require additional refrigerant. Most manufacturers, if that is the case, will indicate either in their specifications or technical guide how much additional refrigerant is required for those matchups. Charging by superheat. Okay, there's many different superheat charging charts out there. So when charging by superheat, you're going to have to refer to the manufacturer's instructions. Superheat measurement. Simply taking a suction line temperature, subtracting your suction saturation temperature gives you your superheat temperature. Most superheat charts require you providing an indoor wet bulb temperature, which you must use either a sling psychrometer, a digital psychrometer, or even a type K thermocouple with a wet wick over it. Will also give you the same wet bulb reading. And then you also have to provide an outdoor dry bulb temperature. Take those two measurements. In this case, we'll use a 68-degree indoor wet bulb with an 85-degree outdoor temperature. Tells us that we have to have a 19-degree superheat. Now, when charging by superheat, you want to be within 2 to 3 degrees of that superheat calculation. Adding refrigerant decreases superheat. Removing refrigerant increases superheat. Charging by subcooling. Again, everybody's charts are a little bit different, but always pay attention to the specific manufacturer of the equipment you're installing installation manual. Okay, use the charts either provided in that manual or on the door of the equipment. The subcooling measurement is going to be your liquid line temperature subtracted from your liquid saturation temperature. Will give you your amount of subcooling. For subcooling measurements, you measure and record the indoor wet bulb temperature. Measure and record outdoor dry bulb temperature, just like superheat. And typically the manufacturer is either going to give you a dedicated subcooling measurement, or they may show you a chart like this where your subcooling changes based on the conditions. So in this case, we're going to use a 100-degree outdoor dry bulb with a 67-degree indoor wet bulb. And it tells us that our liquid pressure should be 235 with an 8-degree subcooling. Adding refrigerant increases subcooling, recovering refrigerant decreases subcooling. So it acts the opposite of superheat. When charging by weight, always try to find a way to mark the total unit charge when complete and permanent marker somewhere on the unit. And when weighing in, before you open service valves, always start by weighing in the additional charge for the additional line set. Anything over 15 feet will save you a bunch of time. And typically, you won't even have to fine tune your superheat and subcooling because they'll be within that 2 to 3 degrees if you weigh the charge in. Always allow 10 to 15 minutes of run time before adding or removing any refrigerant to allow the system to reach a steady state. And typically your temperature drop through an evaporator coil is going to be around 20 degrees unless it is a high humidity condition. Some manufacturers offer basically an airflow chart that will allow you to determine if you're in the ballpark with airflow delivery when charging the system. They will give you typically a target exit temperature for your evaporator coil. So in this case, if we have a 68 degree entering wet bulb with a 72 degree entering dry bulb, tells us our leaving temperature should be 59 degrees. So that'll at least give you an indication if you're in the ballpark airflow wise. Undercharged applications, the symptoms you're going to see are low pressures, high superheat, low subcooling, compressor overheating, low system capacity, poor efficiency, sludge and carbonization in the compressor, refrigerant system, compressor failure, and obviously what we don't want to see is customer complaints due to poor or no cooling. Overcharged system, you're going to get high pressures, low superheat, high subcooling, liquid flood back to the compressor, which is painful, low system capacity, poor efficiency, compressor failure, again, customer complaints, poor, no cooling. Correct charge, it's going to give you long equipment life, safe operation, proper operation, design capacity, peak efficiency, fewer callbacks, and customer satisfaction. Knowledge is power. You know, most people don't spend the time to read installation manuals, and you know, I'm just as guilty as this as everybody else. You know, we get in a hurry, and you know, one of the years that I spent in the field, you know, we never always read the installation instructions. You know, we get to the end of the day, we're wanting to do a start, you know, we're wanting to start it up and get home, and things get overlooked. So installation manuals, always leave them behind with the homeowner. You know, any paperwork that come with the equipment, always leave it behind, because you may not be the one going back there, and somebody may need that information later on down the road. Installation manuals are typically used as knee pads and don't get left behind on the job. What is the one thing almost every volunteer fireman can tell you about a heat pump? They produce steam. So you always want to make sure to communicate any kind of change in application or change in a design of equipment. You know, if you have a homeowner that's going from, a gas furnace or an oil furnace to a heat pump. These are the kinds of things you want to point out to them to eliminate any kind of nuisance calls down the road. Somebody who's never had a heat pump before may not know that it produces steam, and the first time they see it, they're going to think it's smoke and their unit's catching fire. So these types of things always need to be communicated to the homeowners. A lot of the manufacturers in the homeowners section will typically have a lot of this information in there for them. So if you don't have the time to spend with the homeowner, always make sure to point this out, that information is available for them in the user manual or homeowners section. All right, let's talk about some commercial applications here. Proper application would help, of course. I can't tell you how many times I've seen systems like this on a roof of a building. A lot of times contractors will go in and they'll do stuff like this as a temporary solution, and then the tenant or building owner never calls back to have it upgraded to the proper application. Safety should always be the number one concern when dealing with commercial equipment. All right, we've got a lot of moving parts, large blowers, those kinds of things. So safety should always be your number one concern. So safety glasses, gloves, hard hat, safety shoes, earplugs, respirators, safety harnesses. All right, we got to follow the OSHA definitions to prevent any kind of disaster from happening. Definitions when it comes to installation manuals and manufacturers documentation. Danger is an indication that a fault could result in death or will result in death. A warning could result in death. Caution indicates a potential hazardous condition that may result in a minor or moderate injury. But 2 out of the 3 use the word death. So that's the key takeaway here. But nobody wants to see any injuries when it comes to working on a job. Again, we have, rotating components, large components. When you consider a commercial blower, sometimes you're going up against 100, close to 135,000 foot-pounds of torque. So that's not a battle that many people are going to win. In some cases, you're dealing with high pressure gas. 2 pounds of gas pressure, sometimes 5. Depending on the size of the factory or what have you. Some of their production machines could use very high pressure natural gas. So those are the things to be careful of. Jewelry, obviously, electrical conductor, and not only that, they can get caught in something and pull you into it as well. Long hair can also be a big factor, and loose clothing, gloves, things of that nature. Another thing we have to be concerned about is confined spaces. Some of this equipment is large enough that you can actually walk into it. All right, so that's another thing to consider. Lockout and tag out procedures, are critical to use in some of those scenarios. The key on large equipment is don't get too comfortable. Getting comfortable is when people tend to slack a little bit. So don't get comfortable with the equipment. Be on edge, because being on edge is what's going to save your hide in the long run. Okay, you never want to enter a blower section when the blower is running. Always shut that blower down. Use lockout, tag out, especially if the equipment is located, you know, a good distance away from your electric panel or you know, start stop device. And again, if you're planning on being in that blower section for any period of time, you know, use lockout, tag out. Keep anybody from bumping that on while you're in there. Again, loose clothing, you know, around the machine or moving parts. You know, you never know when a unit's going to start. It could tie you up, pull you in. You know, you pray that clothing tears away before it pulls you in. You know, you can't get away fast enough with those moving parts starting up. Things to look for, you know, a lot of rooftop units, things like that come pre-charged from the factory. You know, so just keep an eye out for any, you know, possible obvious leaks. Again, wires that aren't connected, any signs of shipping damage. If the unit contains sight glass, filter dryers, you know, make sure they're, you know, check the moisture indicator, make sure there's no moisture in the system, and make sure the filter dryer is pointed in the right direction with the flow. Check the fan blades, you know, make sure the motors spin freely, you know, check the mounts, make sure nothing's loose, and check your piping supports. All right, Matt, if you would, could you launch the next poll question, please? All right, looks like we got a pretty good majority of votes in. So Matt, go ahead and close it and share the results, please. All right, so it looks like 80% of you selected airflow as the most common issue with startup. Let's see here. Believe it or not, this is the correct answer. The transformer voltage tap is probably one of the biggest things that I see when I get a call from a guy doing a startup on a rooftop unit. What typically happens, they'll forget to change this voltage tap setting, and when you have a system, you know, left on the 230 volt tap when, you know, your voltage is actually 208, the output of the secondary side will drop as low as 19 volts, and then when it put under load will drop as low as 16 volts. And when you have safety circuits looking for a 24-volt feedback, that voltage is low enough to make it think that that safety is tripped. So this is a very, very, very common issue with nuisance faults on equipment. So, checking your safety circuit connections, spade terminals, screw terminals, make sure everything's good and tight, all right, to eliminate any nuisance faults and may cause, a delayed startup. All right, heating, just like, normal gas furnace, you're going to check your gas pressures, set your gas pressures. You're going to want to make sure your ignition wire didn't disconnect from the board. All right, setting airflow. All right, there are a few different ways that you can go about this. Some manufacturers will put airflow, static pressure airflow charts on in their equipment guides. All right, but as far as different motor pulley sizing, things of that nature, with fan laws the way that they are, motor pulley sizing is a lot of manufacturers put motor pulley sizing charts in their documents as well. So, but a simple simple formula here can be determined. You take your desired CFM, divide it by your actual CFM, will give you a size factor. Okay, you take your size factor times your existing motor pulley pitch diameter, and that'll give you your desired motor pulley pitch diameter. Now, when it comes to the mechanical side of fan laws, your fan speed responds directly with mechanical changes. Okay, so for example, if you have a 12,000 CFM desired, you're currently moving 15,000 CFM, you have a size factor of 0.8. Okay, so that means we want 80% of what the actual CFM is. Okay, so if we have a motor pulley pitch diameter of 4.2, multiply that by 0.8, it'll tell us what the new motor pulley pitch diameter should be. Again, some of these adjustments are in manufacturer's instructions. Some of them will give you static pressure ratings. Some will give you the turns open and RPMs. So you always have to pay close attention to those. Okay, blower adjustments now have gotten pretty simple on most commercial product. It's typically some sort of slide rail system, typically easy to get to. Some even have the capability of sliding the blower completely out of the unit. Economizers. All right. Always save jumper plugs removed from installing an economizer. These things are gold, if you will. If you go back on a call and if your economizer failed and you're waiting on parts, you can throw these jumpers in there to bypass and get them mechanical cooling until you can get your parts in for your economizer. How an economizer works, you have an outside air damper and you have a return air damper. All right, and the combination of the two combining into a mixed air section of the unit, we have formulas to use to help you determine what your mixed air temperature should be for proper outside air. Okay, so setting a correct minimum position set point, typically you're going to have some sort of on an application where it's either a design build or a spec job, the engineer is typically going to assign a dedicated airflow quantity for outside air. And they may give it to you in a percentage, they may give it to you in an actual CFM. So with that being said, we have a formula that you can use to determine your mixed air temperature when your minimum position is set to the correct position. That formula is as follows: outside air temperature times outside air percentage plus the return air temperature times the return air percentage will give you your mixed air temperature, your proper mixed air temperature. All right, so if we do an example here, we've got a building that requires 15% of outside air. Okay, the outdoor air is 50 degrees, return air is 78. Okay, so if we take 50-degree outside air times the 15% gives us a 7.5. 78-degree return air times 85% is a 66.3. Add those two together, gives you your mixed air temperature of 73.9. That will get you to where you need to be for your outside air. All right, well, that concludes our webinar for today. We're going to go ahead and open up for any questions or any comments. We would like to hear feedback from you guys. I show my email, on the beginning screen of every webinar, to allow for any kind of feedback. We'd like to hear from you guys, find out, any webinars that you would like to see in the future that we could possibly put together for you. So let's go ahead and open that up now for any of that information.
On how to set up even non-commercial stuff like on your percentage of fresh air you want brought in into your commercial on your economizers calculations. So that's pretty cool. I was just wondering I was just going to ask you how you liked it. I thought it was pretty interesting. Furnace and, yep, it was talking about.
Okay, doesn't look like we have any questions, so we're going to go ahead and sign off for today. In the future, feel free to email us with any, questions, comments, or even, upcoming webinars that you'd like to see us put together for you. With that being said, it is Friday, so everybody enjoy and have a great weekend, and we'll see you next time around.